Hi guys, and welcome to section 4.2, applications and modeling of quadratic functions. And this is going to be probably what you're thinking it is. There's a little bit of word problems going on here, but it's not going to be too bad, don't worry. So we're going to learn how to maximize projectile motion functions, maximize functions in economics, and maximize area. Okay. And really, we're just going to be doing it using our quadratics. So when we have functions that create a quadratic equation, which is anything where the highest degree is 2, then we have this parabola, right? And if they're asking us to find the minimum value, we look down here. It has to be, to find the minimum, it has to be a parabola that's opening up. And then the vertex is the minimum. And if they're looking for a maximum, then it has to be a parabola opening down, because a parabola opening down, again, has a maximum. We talked about this, I think, in the last lecture. So let's look at the actual problem here. So a toy rocket is launched with an initial velocity of 44.1 meters per second from a 1 meter tall platform. Okay, so they're just telling us some information here. Do we need any of it? Probably not. And I'll tell you why in a second. So, sorry. Okay. The height. So what we do need is that the height is h. So here's h. This means that this equation right here is telling us the height, and t is time in seconds. So that's our t's. So we don't have just an xy, we have a t comma h of t, okay? And it says, how long after launch did it take the rocket to reach its maximum height? So that's our first question. Second question, what is the maximum height? Sorry. So let's actually put in some slide here. Okay, so the first question is, how long after launch did it take the rocket to reach its maximum height? Well, that is our t, right? T is time. So when it says how long, basically we're wanting to find out what t is, when the rocket reaches its maximum height. And when will the rocket reach its maximum height? Well, I don't know, but I know it's at the vertex, right? That we know, because we can see that the equation of this line right here, the equation that this would create would be a parabola opening down. So if I want to find my maximum at what time, well, this is t, I'm trying to find that time, okay? And we have our vertex formula to do that. So let me copy this equation over to the next page. All right. And so to find the time when the maximum occurs, so let me write down the time when maximum height occurs. Well, we use our, we have our function that tells us that the x value of the vertex is, but in this case, it would be the t value. So we have t is equal to negative b over 2a, which is equal to negative 44.1 over 2 times negative 4.9, right? And if you put this into your calculator, you're going to get 4.5 seconds. So at 4.5 seconds, that's when the max occurs on our parabola. So if we had a parabola, and let's say this is 4, and this is 5, and our parabola is going to have a maximum at 4.5. I don't know what the maximum is yet, right? But I do know that it's going to occur right here at the top at 4.5 seconds. Okay, now the next question asked, so how long after the launch did it take the rocket to reach its maximum height? 4.5 seconds. What is the maximum height? Now I need to know what the height is at 4.5 seconds, because that's the y value. If I do this, this is time in seconds. And this axis right here is height. Actually, I think it's in meters. Okay. So I just literally plug in. So I have h of t, which is 4.5 seconds, is equal to negative 4.9 times 4.5 squared plus 44.1 times 4.5 plus 1. And again, calculator problem, put this in your calculator and you'll get 100.225 meters. So that's the maximum height. Now we know that the maximum height that it reached was 100.225. Okay, so this point right here has an ordered pair. 4.5 is the time, and 100.225 is the height. And that's really it. So it wasn't that bad, right? We want to find the maximum or the minimum. We're always looking at the vertex whenever I have a quadratic function. All right, good. Let's continue. So if an object is launched at an angle of 45 degrees from a 10-foot platform at 60 feet per second, it can be shown that the height of the object in feet, so this one's in feet, is given by this quadratic function. Now, if they didn't give us the quadratic function, this would be a very difficult problem because we'd have to figure out what all that means. But since we're given the equation, we don't have to worry about all the information above it. We just really want the equation, okay? And we want to know what the variables mean. So it says x is the horizontal distance of the object from the platform. So for example, we can tell this is going to be a parabola and it is going to open down. So right here, it's this is x and x is distance from platform, right? Because let's say the platform is right here and we're launching an object, okay? If we're launching an object from that platform, it's probably, the graph would look more like this. Okay, obviously it's not going down below the line. Anyway, so these are my x values. And h of t, we were told h of t is the height. Okay, so now we have our equation. We know what all our variables mean. And let's see what the questions that they ask are. So the first question is, what is the height of the object when its horizontal distance from the platform is 20 feet? Okay, so not too bad. We just plug in for x, because x is the horizontal distance. So we have, oops, that was not what I wanted to do. So we have h of x is 20 feet is equal to negative 32x, sorry, we know what x is. So we put in 20 squared over 60 squared plus 20 plus 10. And then we get, when we put into our calculator, I mean, I don't think I need to show you how to put this into your calculator. I think if anybody has a problem with that, just let me know. But when we do all the math here, we would get 26.44 feet. So what is the height? This is the height at 20 feet from the platform. Okay, so hopefully that makes sense. Okay, and then let's grab the same equation and copy it again and paste it over. I think there's one more, yep. So now it says, what is the horizontal distance from the platform when the object is at its maximum height? Okay, well, I don't know, right? But I do know that if I look at a graph, so far we know we have a platform. We shoot off an object. It takes this parabolic shape. And we know that at 20 feet, the value is 26.44 feet high, right? This is distance, and this is height. Okay, but what we want to know is what the value is here at the vertex. We want to know what is this value, because that's when the object is at its maximum height. So again, we just need to use our vertex formula, which says x is equal to negative b over 2a, which is equal to negative, here b is 1, over 2 times negative 32 over 60 squared. Okay. So again, we just take out our calculator and our negatives cancel. So our final answer will be, actually, let me put it into a form that'll be a little easier for you to put in your calculator. So this would be -1 over -2 times 32 over 60 squared. And so the negatives cancel and become a positive, right? And we end up with 1 divided by this fraction, which means we just do keep, change, flip. So it's going to be the same as 1 times 60 squared over 2 times 32. And the answer to that is 56.25 feet. Okay, so now we know that when x is at 56.25 feet, that's when the object reaches its maximum height. Okay, then let's see what the next question says. What is the maximum height? Well, that's going to be my y value, right? So I just take that value that I had from before, which is 56.25, and I plug it into this equation. So I have h of 56, right? 56.25. H of 56.25 is equal to -32 times 56.25 squared divided by 60 squared plus 56.25 plus 10. And again, when we do all the math here, we get this to be approximately 38.125 feet. Okay, And the graph would look basically like this. So we know it's going up. So let's read the question again. So the object is launched at an angle of 45 degrees from a 10-foot platform at 60 feet per second. So let's see. So basically, here's our 10-foot platform is at 0, right? So this is 10 feet high. And it's launched at 45 degrees, which is about like that. And it's going to go up and then it's going to come back down, right? That's basically what it's going to do. And we can see that this point right here, which is the maximum height, when did that occur? That occurred at 56.25 feet. Right, this is X in feet. And at that point, it was 38.125 feet high. Okay, that's my vertex. The other question asked, where was it at 20 feet? And we found out that at 20 feet, it was 26.44 feet high. So 26.44. So let's say here is 26.44. So that means that, not too bad. That's the point. And you can see that there's going to be another point because it's going to come down. So there's another point when it's going to be 26.44 feet high. If that was the question that was asked, when is this object going to be 26.44 feet high? Well, it's going to have two values. One's going to be 20 feet and the other we don't know yet, right? Because we have to figure that out. But it will be, actually, we can pretty much tell just if this parabola started at 0, this midpoint here, that's our axis of symmetry. So since the distance from here to here is 35.75, that means that the distance from here to the next time it reaches, it will be exactly the same. But that's not a question that's being asked. It's just a little bit of extra info. And that's really how you do these word problems. They shouldn't be too bad. So for this one, I want to explain a little about what all of it means. So we're going to talk about a function in economics. And first thing they're talking about is dollar amount received by selling X items at a price of P dollars per item is this. So first, let's talk about what does revenue mean. Revenue means, let's say you go to the dollar store because the dollar store is real easy, okay? So everything costs $1. And if I buy 30 items, let's not talk about tax. Let's say I buy 30 items, I know it's going to be $30 because I multiply the number of items by the price, right? If we went to a place where it was $2 per item, then, and I bought 30, it would be 2 times 30, which is 60. That's how, when you go to the cashier, they say that'll be $60. That's revenue. Like if I had an empty cash, if I was a cashier and I had an empty cash register, revenue is how much I have at the end of the day in the cash register. It doesn't have to do anything with what I made. It has to do with exactly the amount that I sold, that I brought in, okay? So here it's telling us as quantity X increases, the price P tends to decrease. Well, why does that happen? Think about it. Let's say we're gonna make, let's see, what can we make? We're gonna make cars, okay? So I am a car maker, not a dealership. I make cars. And to make a new car costs quite a bit of money, right? I first have to pay rent on a building. I have to, or buy a building, whichever you want to do. I have to hire employees and I have to pay them. I have to pay my electric bill. I have to pay my employees. I have to buy materials. I might have to buy a bunch of new equipment, right? There's a lot of startup costs in making a new car. So if I sell, let's say it costs $1 million to get started. After I finish, I've spent $1 million to create this new car that we're going to make a lot of. So if I just sold one, I'd have to sell it for over $1 million to recoup how much it cost me to make that car, right? But if I make two cars, well, now it only costs me half as much to make because I have two cars, and that other car maybe costs a few $1,000s in materials, but all the other stuff was already taken care of, right? And if I sell 1 million cars and it costs me $1 million, and let's say it costs me $5,000 per car to build, well, so that's $1,000 plus $5,000, which is $6,000. So now it's really only costing me $6,000 per car because I've made 1 million cars. I made one, it cost me $1 million. I make 1 million, it costs me less. So the more you make of something, the less you have to charge because you're spreading that initial cost over over more items. That's why as the quantity increases, the price tends to decrease. And conversely, as the quantity decreases, the price tends to increase. I think we've seen that all with inflation. We kind of know that that's true, right? So also, if I take the revenue, which is how much money I have in the cash register. So let's say, for example, at the end of the day, I have $100 in my cash register. Okay, I sold 100 things. I'm at the dollar store. But each thing cost me only 25 cents. So now I subtract the cost, which is, I'm at the dollar store, so it's 100 times what it costs me, which is, it only cost me 25 cents to buy each one of them. So my profit is going to be 100 minus $25, which is $75. That's my profit. Okay. Now, out of that, maybe that's not my complete profit because maybe I have to pay my rent, and all those things. But just in general, that's why profit is equal to revenue minus cost. How much I bring in minus how much it cost me for the items that I sold. Okay, so let's do an example. It says records can be kept on the price of shoes and the number of pairs sold in order to gather enough data to reasonably model shopping trends for a particular type of shoe. Demand functions of this type are often linear and can be developed using knowledge of the slope and equations of lines. So suppose the marketing and research department of a shoe company determined that the price of a certain type of basketball shoe obeys the demand equation, and this is what I need. This is the demand equation, okay? So let's just copy that. We need it and see, yep, we do. Oh, I got the wrong thing. Cut. Cut that out. All right. So according to the demand equation, how much should the shoe sell for if 500 pair of shoes are sold? Well, this is my demand equation, and the price is equal to -1/50 times X. And X is the number of shoes sold. So for the 500, I just type in 500. I put in 500 here. And I say plus 110, which equals, well, 50 divided by 500 is 10. So we get minus 10 plus 110, which is equal to $100. So if I am going to sell 500 pair of shoes, I need to charge $100 a pair. Okay. If I were to sell, this is for 500 pair. But if I were to sell 1,200 pair, how much would I have to charge? Remember, I already have everything set up to make these shoes, so I don't need any new equipment. So it's not going to cost me any more than just the basics of what it costs per shoe to make. And this becomes $86. Okay. So again, the more I sell, the cheaper I can sell it for, right? And that's really all I need for question A. And we can see that if we plot these 2 points, let's see. So let's say this is 500, this is 1,000, and that's 1,500, 500, 1,000, 1,500. And let's call this 100. And make this 50. And let's make that 75. Okay, I think that's enough. So at 500 pair of shoes, it cost me $100. And at 1,200, let's say that's 1,200 right there, it cost me $86. And we know this is a linear equation, and we can see that it's got a downward slope. Okay, so again, the more shoes I sell, the cheaper I can sell them for. Okay, so it says, what is the revenue if 500 pair, I don't need this, I guess, for this part. What is the revenue if 500 pair of shoes are sold? Well, oh yeah, I did need it, sorry about that. So I know that R is equal to X times P. So now I know that R is equal to X, but I have an equation for P. It's minus 1 over 50 X plus 110. And I distribute this, I get negative 1 over 50 X squared plus 110X. And now we can see that this is the revenue as a function of X. Now I can see that it's a quadratic, right? So we know now it looks like a parabola. And so we want to know, well, we have this equation. What's going to happen when I sell 500 pair of shoes? So R of 500 is equal to negative 1 over 50 X squared plus 110. Sorry, we already know what X is, so we plug that in. So 500 squared plus 110 times 500. And obviously, when I get out my calculator and I do all the calculations, the answer here is $50,000. So that's my revenue. That's not my profit. It's not my cost. It's my revenue. If I sell 500 pair of shoes today in my store, at the end of the day, I should have $50,000 in my cash register. Okay, that's basically what that means. How much money is actually coming into the store? What about if I sell 1,200 pair? If I sell 1,200 pair, I just plug in 1,200 plus 110 times 1,200. And when you do the calculations for that, you get $103,000. So I doubled my money a little bit more than double, but I more than doubled the amount of shoes I sell. So, it's working out that it's almost the same, right? We're almost like making the same amount, even though probably I'm charging, for the second one, I'm charging less. How many pair of shoes should be sold in order to maximize revenue? So if I want to maximize revenue, I have to use my revenue formula, which is this right here. Hopefully I grabbed it all. Let's see. Yeah, looks good. All right, so there's my revenue formula. And we can see again that this is a parabola and it's opening down. So my maximum is going to be at the vertex. So how many pairs of shoes? Well, X is equal, how many pairs of shoes? Actually, it says how many pairs of shows. Hold on, let me fix that. Shoes should be sold in order to maximize revenue. So first question is, how many pair of shoes? So I still need, remember, this is my graph, and it's going to be a parabola opening down. And to maximize revenue, this is revenue, is the y-axis, and the x-axis is number of shoes. So again, I need to find what my vertex is. So how many pairs of shoes? Well, that's the x value of my vertex. So I would just say x is equal to negative b over 2a, which is negative 110 over 2 times negative 1 over 50. The negatives are going to cancel. This becomes negative 110 over, I'm sorry, I didn't cancel a negative, so I'll just keep the negatives for now. 2 over 50 is the same as 1 over 25. Now we're going to say the negatives cancel. So we have a fraction over a fraction. So we say this is 100, keep, change, flip. Okay, so now we know that that answer is going to be, sorry, this is 110. So my answer is going to be 110 times 25, which is 2,750 pair of shoes. Okay, so I have to, so in order to maximize revenue, that means that's the perfect spot for me to bring in the most money. Okay, if I charge too much, then there's a lot of people that won't be able to buy those shoes. If I charge too little, then I could probably be losing money. So I want to find the exact right amount to maximize revenue. How many pairs? Oh, we already did this. Sorry. Is that B and C? No, I just have it here twice. Okay, sorry about that. And then it says, what price should be charged in order to maximize revenue? Well, we go back to our P function, our demand function, because that gives me the price, right? So I have this price, and I know that I have X is equal to 2,750 shoes. That will maximize my revenue, right? Oops, so sorry. Here we go. So P is going to equal negative 1 over 50 times $27.50 plus 110, which is going to equal $151,205. That is not the right answer. Sorry about that. That is definitely not right. So let me do this again. I can tell that's not right. Like, I can't charge that kind of money. That is probably my maximum revenue. So hold on, let me get my calculator out and do it again. Okay, so calculator 2750 50 plus, it's $55. Sorry. So this is $55. Okay. And so hold on one sec. Okay, so if I charge $55 for each pair of shoes, I will make the maximum amount of revenue that I can, which means that's the most I can bring in. And that's really what I want. I want to sell the most shoes. I want to bring in the most money I can, because the more I sell, the more profit I'll make. Okay, and that concludes that problem. Now, the next problem is we're going to do a rectangular pen. Okay, so Mark has 100 feet of fencing available to build a rectangular pen for his hens and roosters. Okay, just like the picture below shows. He wants to separate the hens and roosters by dividing the pen into 2 equal areas. What should the length of the center partition be in order to maximize the area? So basically, if this is the center partition right here, I'm trying to find out what X is. And the only thing I'm really being given here is that I have 100 feet of fence, which means that I need 100, like I can only pen in, or what would I say? I can only put the fence where it says here, but I only have 100 feet of fence. So it's not like I can build it as big as I want. I can only build it as big as 100 feet of fence will build. So basically what I need to do is I need to add up where the fence is. So the fencing, which is really the same as the perimeter. The perimeter is the outside of each pen, so they're similar, is 100 feet. So let's see, this is also going to be Y. So where the fence is going to be, I have 3 times X, because I have, this has got to be fenced, and this has got to be fenced, and this has got to be fenced. So that's X plus X plus X, or 3X. And then plus, also, what else has to be fenced is this and this, right? So that is Y plus Y, or 2Y. And that's the most it can be is 100 feet. That's all I have, okay? So here we do need to know these numbers, because they're not giving us an equation. So let's see. We want to know what, basically they're asking us, what is the length of the center partition? So I want to know X equals what? Really, that's my question. In order to maximize area, so we're not really concerned about this. What we want to do is maximize the area. And the area is equal to, so the area is equal to length times width. And in our case, if I call this L and I call this W, it would be X times Y, okay? So, okay, we're getting closer, but I know that A equals X times, well, I have X times Y. That's not really helpful, right? So what do I do? Well, let's solve this first equation. Let's solve this first equation for Y, okay? So that means I'm going to subtract 3x from both sides. So I get 2y equals 100 minus 3x, and then I divide both sides by 2, and I get, let me write it here, I get y is equal to 50, 100 divided by 2, minus 3 halves times x. Okay, that works. So now I know that the area is equal to x times y, but y is equal to 50 minus 3 halves x. And then let's distribute. We get 50x minus 3 halves x squared. And let's put it into standard form, minus 3 halves x squared plus 50x. That's equal to the area. So now I have really got my two equations. Or actually, I only need this one equation. So I know I want to maximize this, right? And I came to it by knowing how much fencing they gave me. Is that, hopefully that's clear. All right, so let's continue. Let's see if I can remember it. So to maximize area, I have area equals minus 3 halves x squared. So area equals minus 3 halves x squared plus 50x. Okay, and now I want to maximize area. Well, I have a quadratic. It's open. It's a parabola opening down. So again, to maximize, I need to find my vertex. So I first start with x equals. So x equals negative b over 2a. And remember, there's a plus 0 here, which is my c. So is my c. So this is b, and this is a. So this is going to equal negative 50 over 2 times negative 3 halves, which is equal to, well, the negatives are going to cancel with each other, make them both positive, and this 2 can cancel with that 2. So what I end up with is 50 over 3, 50/3, which simplifies to 16 2/3, or some decimal value if you'd rather. Okay, so that gives me what my x is, which is one of the questions, right? Hold on, let's find it. So first question is, what should the length of the center partition be in order to maximize the area? Well, we just found it. X has to be equal to 16 2/3 feet. Okay, feet. And then the next question says, what is my maximum area? Sorry, I keep getting to the wrong place. Yeah. What is my maximum area? My maximum area, hold on one sec. All right, so we have our area formula, and that's all we really have left to do. So I don't know if this is, yeah, that's just the, let me delete that. And let me grab. Oh, we already had it here. All right. So we have our formula, and now we know what x is. So to maximize the area, we found what x is, and now does it ask what is the maximum area, I think? So what is the maximum area is what we're doing now. So this is what is the max area, okay? And we just plug in our 26, I'm sorry, our 16 and 2/3 feet. So this becomes minus 3/2. X is 16 and 2/3 feet squared plus 50 times 16 and 2/3. And when I do the math on this, I get 416 and 2/3 feet, which also would be the same if you're trying it on your calculator. It should be like 667 feet. I don't know what to round it to. So that pretty much takes care of this section 4.2. I hope everything goes well. If you have any questions, don't hesitate to ask. Thank you so much.